Happy Saturday, scientists! Let's review. It's time to refresh our memories with the properties of the main elemental groups, as well as how chemical reactions happen and what their properties are likely to be. That's right, today's topic is C4, predicting and identifying chemical reactions and products. Let's begin. This topic begins with the properties of the group 1, 7, and 0 elements. Remember that both Mendeleev and the modern periodic table group elements based on similar properties. We know that these properties are from their electronic structure, but the groupings from Mendeleev's day are no less valid than they are today. Let's begin with the group 1 elements, or the alkali metals. These elements have all the properties you would expect of metals, and in addition to this, they all have one electron in their valence shells, or their outer shell, depending on which terminology you are using. If you react them with water, they will form an alkaline solution, hence their name. Because of the one electron in their outer shell, these are all highly reactive. All they need to do is lose that one electron in order to react. As you go down the table, you'll find that the trend in reactivity is an increase. So the least reactive alkali metal is at the top of the periodic table, and the most reactive alkali metal is at the bottom. This whole group is their chemical properties. If we take a look at their physical properties, as we've said, they will already have those typical properties of metals. For instance, they are shiny, they're conductive. At room temperature, you'll find that the alkali metals are solid. As you go down the table, you will see that the density of the alkali metals increases, but none of them are very dense, so they're rather soft. You've probably seen a demonstration in class where your teacher cut them with a knife. The melting point of these metals goes down as you go down the table as well. Let's move now into the group 7 elements, or the halogens. You may find these labeled as group 17 on some periodic tables. The chemical properties of the halogens come from the fact that they are only missing one electron in their valence shell, so they need one more electron in order to have a full stable shell, and this makes them very reactive. In terms of their chemical properties, you can expect elements that will react to form acids when they are reacted with water. So, for example, hydrochloric, hydrofluoric, and hydroiodic acids are some of the strongest acids we know. You will find them highly reactive in any chemical reaction. As you go down the periodic table, you'll find that this reactivity decreases. So it's the opposite to the group 1s. The most reactive nonmetal, or the most reactive halogen, is at the top of the group. In terms of their physical properties, you'll find that they are typical nonmetals. They're not very shiny. In solid form, they are brittle. They all have some form of colored form. So as you go down the group, what you will see is that fluorine is a pale yellow gas. Chlorine, underneath fluorine, is a pale green gas. Bromine is an orange or brown liquid. And these are all properties at room temperature. And then with iodine, we would be looking at a gray solid. However, iodine is able to sublimate, that is to change directly to a gas. And in this case it forms a purple gas. So you should note that the melting and boiling points are increasing as we go down the halogen group. The further down the group you are, the higher those melting and boiling points are, and this is made quite obvious by the changes in state as you go down. Their density will increase as you go down the group. We'll move now into group 0, or the noble gases, sometimes labeled as group 18 on a periodic table. As you would expect, these are unreactive, and this is because of their full outer shell of electrons, or full valence shell. While they do still have some useful properties, they are not going to participate in reactions. This is important as we can use them when we need a task where we don't want a reaction, so we can use them as an inert gas to store different compounds that are sensitive to chemical reactions. You'll find that they are also monatomic. This means that unlike the halogens, which are diatomic, these only come in groups of one atom. In terms of their physical properties, you'll find that as you go down the periodic table, you will experience stronger attractive forces between the individual molecules of each atom. You will have an increase in boiling points as you go down the table. And you will also have an increase in density as well. And just to clarify, both of these are as you go down the group, so remember that trend. Now that we have some ideas of the properties of the groups, we can start to understand how they may react with each other, or in the case of the noble gases, not react. We can also begin to understand the general structure of some chemical reactions, and we can use these trends in reactivity to predict the results of those chemical reactions. Let's begin by looking at a category of reactions known as the halogen displacement reactions. In this case, the term displacement means that we will be replacing each other. So one halogen is going to replace the other halogen in a chemical reaction. This will happen when you have a compound that contains a halogen reacting with another halogen. If the halogen it's reacting with is more reactive, then it will displace that. So if we go back up to your halogens and you look at decreasing reactivity down the group, this will be the key to this. Let's look at an example. If we have chlorine gas reacting with sodium bromide, we need to predict if there's going to be a reaction here. So we need to compare the reactivity of chlorine and bromine. Chlorine is above bromine on the periodic table, and we remind ourselves that in terms of reactivity, the highest reactivity is at the top of the group and the lowest is at the bottom. If chlorine is above bromine, then chlorine will be more reactive and it will be able to displace or replace bromine in the sodium compound. So we should end up with sodium chloride and bromine coming out of this reaction. So we should end up with sodium chloride and bromine as products of this reaction. When you look at metals, we're also able to see similar trends in reactivity and in understanding an order of reactivity for the metals. This can be done by reacting the metal with different compounds to see how it behaves. You begin by reacting it with water. If it reacts easily with the water, then you know that it is highly reactive. If it doesn't react with water at room temperature, then you may increase the temperature of the water in order to see if it reacts. And finally, you may try reacting the metal with acid. If it's very weakly reactive, it may only react it with a stronger acid. Let's take a look at an example. Here we have the results of 3 different metals and their reactions with water, with hot water, and with acid. The goal here is to place these in an order of reactivity, so we want to be able to look for the most reactive and the least reactive of these metals. More reactive metals react with water at room temperature. Unfortunately for us here, we can see that none of them react with room temperature water, and so that makes it slightly more difficult in order to determine, and they all react equally with hot water. So we know that they're not extremely reactive metals, and it will come down to their reaction with the acid. If we take a look, it indicates that tin gives us some small bubbles, that magnesium reacts to produce hydrogen. This means that they have produced enough gas to test that gas. We know that tin would also produce hydrogen, but they're indicating that they weren't able to test it. And here we know that the aluminium reaction is similar. So this tells us that tin is the least reactive, aluminium is in the middle of these three, and the most reactive here is going to be magnesium. We're using the data that were provided in order to determine the reactivity of those metals. You might be asked the reverse question. They may tell you that you are dealing with a very reactive metal and ask you to predict its reactions with various different compounds. Remember that if the metal is extremely reactive, you would also want to talk about the safety precautions that you would take, and it may not be safe to react that metal with hot water or acid. I hope that you found this quick video on C4 useful. As always, if you have any questions, please ask those in the comments below. We've prepared a revision worksheet for you, and the link to that is in the video description. Good luck with your studying and happy sciencing!